to hear tonight all the latest in research that's being worked on. It's incredibly impressive, and I know you're going to walk away tonight really energized with a lot of great information. So again, thank you so much for joining us. And this is a presentation from our Desert West chapter. So Desert West is Arizona, Nevada, and New Mexico. So this is just for our chapter, and we're so lucky to have Dr. Van Dyke as our mission impact volunteer, because Dr. Van Dyke is a board certified dermatologist as well as a T1D mom. So together that makes the perfect person to present this information with that scientific mind and the passion to get towards cures. And I know you're going to love hearing from Susan. But just taking a quick step backwards, I just wanted to mention Breakthrough T1D new name. It's becoming really easy for me after about 6 months of rebranding to say Breakthrough. It was a little bit of a mouthful in the beginning, but so important that we changed the name. And I'll tell you one reason why. Over half of the diagnoses now of type 1s are adults. And we just wanted to make sure as an organization that no matter what age you are, that you know that there's an organization for you for support, for hope, for education, that do advocacy work on your behalf, talk to the FDA on your behalf, all as we get towards cures. And until we're at cures, to make everyday life better for type 1s. So I just wanted to mention our new name just in case those that have joined us may not know why. So without further ado, I just wanted to, I'm so thrilled to introduce Dr. Van Dyke. And at the very end, put your questions in the chat. We do have the questions from those that put them in at registration, so you don't have to enter it twice. We've got those. But any new questions, put them in the chat and we'll have a Q&A at the end. So welcome, Dr. Van Dyke.
Thank you. Thank you very much. This is very fun to be home doing this. I mean, Zoom, I know we've been doing Zoom for a long time, but in my day, we just used to be in the same room with everybody else. So it's always odd for me to be talking to a screen, but I know I can feel your presence out there, and I'm so excited to be with you. So let's get started. Breakthrough T1D Mission and Research Update. As Christy said, I am now a mission impact volunteer. I used to be a research information volunteer. It's the same job, but it changed the title when the name of the organization changed. And it's just to change the emphasis on what we're wanting to communicate. So yes, I want to communicate what's the new research, because that's what gets me so super excited. But also the impact that the mission of Breakthrough T1D has on the entire disease of type 1 diabetes, and ourselves, our loved ones, our family members. We're all here because we have some really strong connection. And what I want to get across is the impact of what Breakthrough T1D does on everybody's lives and our families' lives. So let's get going. And please, if you have questions, go ahead and stick them in the chat. That'd be fabulous. And I will, to my best ability, answer them. And if I can't answer them, I will get the answer. It's full disclosure. I'm not a researcher. I'm a dermatologist. So this is not my day job. So I don't know everything, but I can find out everything. So this is the mission is to accelerate, and you're going to hear that word accelerate a lot tonight, because accelerate is what we want to do, is to get to that cure faster rather than slower. The reason that I'm so excited about it and got interested in it in the first place, of course, is like many, my son Brian was diagnosed at the age of 21, which points to the fact that we don't call this juvenile diabetes because that doesn't really exist. It's type 1 diabetes. Half of the people diagnosed today are above the age of 18, as Christy pointed out. And Brian's one of them. He's had it now for 12 years. He's doing great, although we had some seriously rocky times in the beginning. A 21-year-old is, a boy in a man's body, kind of, and it was quite the adjustment for him in his life. So let's carry on and see what's new. So the challenge, to some degree, has changed, and I'll explain what I mean by that. But Breakthrough T1D that organization, our organization, is uniquely positioned to break through, get that, breakthrough, the interlocking barriers that prevent solutions from reaching people. So it's not only about the research, it's about getting the research all the way to a solution for for the people who need that solution. And to address that, a new emphasis was or initiative was announced in November 2024, so just a couple of months ago, and it's called Project Accelerate Cell Therapy, or Project ACT. So we are now working within the framework of Project ACT to some degree, on the research side. So what does that mean? Well, Project ACT, Accelerate Cell Therapies, meaning how can we get to the answer to the cure as quickly as possible, at the same time not neglecting our other missions, which I'll touch on as well. But it's an initiative that helps us focus on not only doing the research, but um, coordinating all the steps to get it in the hands of the people who need it. So we look at our pipeline, our core strength as an accelerator. It takes billions and billions of dollars, or to get even one single therapy from discovery research. Discovery research just means what's happening in the lab. Some scientist has an idea, they start messing around with it, with test tubes, and then maybe with animals. And then at some point, it has to go to a therapy. Does that idea translate into something to treat a condition, in this case, T1D? Then once that has developed, you got to get it through regulatory. So in the United States and in many countries around the world, there's an organization that makes sure that only things that are going to help people get through the system. You know it as the FDA, our FDA. So that's regulatory. Then once it's through regulatory, coverage has to do with insurance, who's going to pay for it, and an adoption. Are the doctors, are the providers going to understand, to know about this treatment? Are they going to embrace it? And are they going to deliver it to their patients? So what Project ACT mean is to influence all of these steps at the same time, so that we're not doing one thing and then the next and then the next, if that makes sense. So looking at that, you can see research, therapy, and discovery is number one, and then product development. So product development means you're taking the research and making it into a deliverable for the patient. Um, Breakthrough T1D has experts in all of these fields. So as a company or a university is developing a therapy, our experts can go in and give them advice and help them out and share our knowledge or their knowledge to develop that product to the next step. Then there are the facilitators, which are initiatives to support therapy development. What does that mean? Well, companies are the ones who develop these treatments. So Breakthrough T1D is there to help the companies to understand how to better develop a product, and also how to bring it to regulatory, to the point where when a study goes to the FDA, can you imagine how much paperwork, how much red tape one has to jump through? Well, we have experts in Breakthrough T1D who understand that and can walk companies through it to get it to the next step quicker. I'll move this over here a little bit. Then we've got access, which has to do with talking to the insurance companies, informing them, educating them what is necessary and what is important in T1D, and then adoption, training, putting on seminars, etc., to get the providers, the ones who provide the treatments, to understand and adopt. And all of these are ongoing simultaneously. So let me give you kind of an example of the impact, what the mission impact has been. The Artificial Pancreas Project is something developed by Breakthrough T1D way back 10, 12 years ago. So it helped to develop the Medtronic, the first sort of stab at an artificial insulin delivery system, or what was called the artificial pancreas originally. And you can see through every year in the past decade, starting in 2019, something happened. A new kind of tech was brought onto the market, or was studied, or was advanced. And it is now accelerating that now we don't have just one new technology being introduced. We have multiple ones being produced so that in 2024, just last year, people with living with T1D had multiple choices of um, artificial insulin or automatic insulin delivery systems to choose from. And all this was because all of those steps that I just outlined were addressed to get it from beginning to end. And it's also a template for cell cures. So cell cures, to me, I mean, technology is fantastic, but that's not going to cure anybody. That's going to make lives better. What cell therapy is really the cure. And if you break down how this has been addressed in the last, again, now we're talking 24 years, to use an example of sort of the hallmark cell therapy. There's a Dr. Melton who was sort of tasked with the project of create some stem cells that will make insulin that can be put into a person, which will essentially cure the disease. It took him 14 years, but he did it. But then that wasn't it. You couldn't stop there, right? Now you have to develop into a therapy. So he developed a company supported and funded and helped out by T1D, um, called Sema, which was then picked up by another company with some seed funding from the T1D fund, which is Breakthrough T1D as well, by Vertex. Vertex then started doing studies, which then got through the FDA. Again, here's another touch point that we have to get through, um, that has been worked on from the beginning to make this more rapid. And we've got Vertex announcing that it's acquiring another company. It's getting bigger and bigger, and another study of cells that are injected. And then where we are today, which I'm going to touch on in a minute. So let me go back just for a second, because I know there are a number of people on this call, some of which are veterans and know everything there is about T1D, and some who may not know so much. So let's just touch on what in fact is type 1 diabetes. Well, it's not juvenile diabetes. We've already discussed that part. It's chronic, no cure yet. And what's happening? Well, the cells in the pancreas that make the insulin are destroyed by the immune system. You have no control over that. Insulin is a substance in the body that is required to live. If you don't have insulin, you cannot live. Insulin, its main function is to help cells use glucose for energy or sugar or food. And what results is a disease burden, which is 24/7, every day, every year, year after year, forever. This is what we want to change. So I say it's an autoimmune condition. What exactly is the immune system doing? Well, we've got several stages here. So I'm going to start over at stage 0, let's call it, far left-hand side. So stage 0, you have a beta cell. A beta cell is the cell in your pancreas that produces insulin. And you have a person who has a genetic predisposition to having something go wrong. There are 60 plus genetic locations on the chromosomes that predispose an individual to developing type 1 diabetes. That's just innate in your DNA. That does not mean you're going to get it. There's something that happens, something in the environment that triggers the immune system. Maybe it's a virus, maybe it's pollution, maybe we don't know. We haven't figured it out yet, but there's something that triggers it. And in people who have the genetic predisposition, what happens is their immune system, for some reason, starts shooting out antibodies that tag the beta cells. It flags them. It says there's something about these beta cells. At that stage, we call it stage 1, you can detect antibodies in the bloodstream, but there's nothing wrong. Nothing wrong. Stage 2, the antibodies are there, but now they have brought in, because they're little flags that say, come over here, I'm here. They've brought in the T cells, which are immune cells. And the T cells then destroy the beta cells. The beta cells make the insulin. That's stage 2. So at this point, you've got antibodies that can be detected in the blood, but you're also starting to lose function of the beta cells, meaning you're not making as much insulin as you should. but you're still making enough. You don't need insulin. So at stage 2, people don't have type 1 diabetes yet. Stage 3, this is an ongoing process that right now we don't know how to stop. More beta cells are lost, less insulin is produced, and at that point, you've reached the threshold. I don't have enough insulin to go on. And that's where people get very sick, and that's when the diagnosis is made. And the process does not stop there. It goes on to what we call stage 4 or established T1D, and eventually all the beta cells will be killed. At that point, you're well established T1D. There's another way of looking at it, the different stages. And the stages are super important because they help us understand how to attack the condition. So if you go back to stage 1 and the autoimmune trigger, right now we don't know how to influence that. That's stage 0, excuse me. Stage 1, blood sugar is normal. You have more than 2 autoantibodies, again, can be detected in the blood. That's early detection. Extremely important because all these people who have the 2 antibodies or more will eventually develop type 1. It's about 50% will do it in 5 years, but in a lifetime, it's 100%. When you get to stage 2, you've got antibodies and now the blood sugar is not exactly normal. You don't need insulin, you don't have type 1 yet, but blood tests will show that it's dysglycemia, meaning the blood sugar is not being handled normally. At that stage, you will develop T1D within 5 years. This is where you get into what are called disease modifying treatments, ways to slow down, delay, halt, maybe eventually reverse, while you still have beta cells that work really well and you know what's going to happen. But if you can get a treatment in there, usually it's an immunotherapy. Immunotherapy meaning it gets in there and it slows down what the immune system is doing while it's in the middle of attacking your beta cells. So it like stops that process. Once you're to stage 3, you still have beta cells. So stage 3, if you get someone who's very early in diagnosis, some of these immunotherapies will work on them and they can slow down the progress of T1D. We don't know how to stop it yet. And then you see where it says regenerative therapies. Regenerative therapies means, and this is another aspect of what is being studied, is how to regenerate the beta cells, the cells that make insulin. So as long as you've got some in your body, there's hope that you can make more. Once you fall over into stage 4, no more beta cells, then that's where cell therapy treatments come in. Cell therapy treatments are a way of replacing the beta cells, and it's the only way to get someone with T1D to start making insulin again or to make up their lost insulin. Just to touch a little bit on the symptoms of T1D and kind of how they relate to what's going on. If you don't have insulin, you can't use sugar. If you can't use sugar, it builds up in your bloodstream. If it builds up in your bloodstream, your kidneys are going to try and get rid of it because it knows it doesn't belong. And that results in it's peeing a lot. It's called polyuria because your kidneys are trying to flush out all of this sugar. As they're flushing out the sugar, they're flushing out water. If you're flushing out a lot of water, you're dying of thirst because you're so dehydrated and you're tired and you can't breathe right because you're dehydrated and you're not getting any nourishment, really. You're literally eating like a fiend because you're starving. You're eating and you're starving simultaneously, and you lose weight. All those things make sense. You have a dry mouth because you're dehydrated. The blood sugar affects your vision just by osmotics, meaning your blood gets thicker and it causes the cornea to swell, so your vision will change temporarily. And then lastly, which is actually not last, but the first part of the second row, is that there's a fruity odor. And what is that fruity odor? Well, the fruity odor comes from if you can't use glucose to run your body doesn't give up. What it does is it starts burning fat. And you can live on burning fat for a while. The problem with burning fat or utilizing it for energy is it produces ketones and acetone. You know what acetone smells like? It smells fruity. So ketones in the blood builds up and you have this strange odor. It's not a good thing because if you have ketones, you are building up acid in your blood. And that is where a lot of, particularly children, present with T1D in what's called DKA, diabetic ketoacidosis, meaning no insulin, can't use sugar, burn fat, get ketones, get acidotic, and it's life-threatening. So how is this different than type 2 diabetes? Well, type 1 is autoimmune. You can't control it. You have no control over it. Type 2 is metabolic, meaning you do have insulin when you have type 2 diabetes. It's just that you're resistant to it. You need higher quantities of insulin to get it to work properly. And this is probably a result of a metabolic change, overweight, under exercise. It can be somewhat prevented and delayed and improved by diet and exercise. My brother is a type 2 diabetic, and he went on Ozempic and lost a great deal of weight, which improved dramatically his blood sugars and reversed a lot of his disease. Clearly, this does not work with type 1. So, what is Breakthrough T1D's primary focus? Is to accelerate, remember that word, accelerate cures, while at the same time advancing next generation treatments. So, we're not going to forget the fact that people with T1D are living with disease and need improved lives while we're going for a cure. So there are really three buckets that we're looking at. The first one is delaying the onset of the disease. So this is disease modifying. This is what we're using medications to tamp down the immune attack on your beta cells. So it can delay, slow down, and prevent to some degree the onset. It can't prevent it completely, but that's the goal of type 1. And this requires early detection. So you go back to my stages. If we can detect someone in stage 1 when they have 2 antibodies and get them on these disease modifying treatments, hopefully we can prevent at some point them getting the disease at all. Second bucket, improve lives. So you've already got your type 1, your beta cells are pretty much gone. What do we want to do to improve lives is improve the control of the glucose, because with everything that we have today, it's not a perfect world. People have highs and lows, and the burden of managing it is immense. We still have long-term complications that are happening because we can't perfectly control blood sugar. Complications come from having prolonged high blood sugars usually. And then the psychosocial impact is huge, as we all know. And then the third bucket is cures. Cell therapies. This is the big, exciting, fabulous, this is where our cure is going to come from. And lab grown beta cells are what's going to help people who are in the stage 4 who have already lost all their beta cells. And one aspect of lab grown beta cells is then genetically editing those beta cells and perhaps immune cells to make them behave better so that the symptoms of the disease do not happen. So let's talk about cell therapies first. The goal of cell therapy is to restore insulin. So cell therapies are a way to replace insulin producing beta cells back into the body and to keep them safe. Now, you can't just take beta cells, put them in a body and expect them to do well, because the person with T1D hates their own beta cells and is going to kill them. So that is one hurdle. You have to deal with the immune system attacking the beta cells. Even if you give people new beta cells, you still have that same problem. And also then we have to develop a source of hopefully unlimited supply of beta cells so that everybody can have them, and develop ways to keep them safe so that the immune system doesn't go and destroy them again. Ideally, at some point, we wouldn't necessarily do just a beta cell. A beta cell is the cell that makes the insulin, but there are other cells in the islets, in the pancreas, that make up this own kind of mini organ that controls our blood sugar. So beta cells make insulin, alpha cells make glucagon, which actually raises the blood sugar. And then delta cells helps to modulate glucose. So if we had all of those cells together, then that's where you get the best balance of blood sugars. So a lot of times in the research, you're looking at islet cells that are being transferred, not only beta cells. And that's one thing we have to look at more. So can we cure type 1? Actually, we can. It's called a pancreas transplant. And the first one was done in 1966, but it's a major surgery. So the major surgery is generally done when a kidney transplant is done. So these are extremely, extremely ill people. Only a few hundred a year are being done. Because of that, you need a donor for the pancreas and the kidney. And so that means a deceased or a cadaver donor. So there's a very limited supply of that, of course. And then once you get the new organ, it's lifelong immunosuppression. So less than ideal, only available to the sickest of the sick. But it proves you can cure it because it works. So Lantidra is an FDA approved treatment that comes from that concept of those cells can be curative. They come still from a donor, a cadaver. In this case, it's not the whole pancreas that is transferred, it's just the cells, so that the islet cells are removed from the pancreas, isolated, and then they're infused into the person through a large blood vessel. And then those cells take up residence in the liver and they work. They will produce insulin. In about 80% of people who are treated, they can become independent of insulin completely. And so essentially it's a functional cure of type 1. They, however, do need lifelong immunosuppression. So the next step is, how do we do this? Get those beta cells into people, but don't need a donor. That's where Vertex and other companies, but Vertex is sort of one of the leaders, have been working on growing beta cells in the lab. Remember, I mentioned Dr. Melton being a pioneer in this. So this is now done. Beta cells are grown in the lab. They come from stem cells, and they can, in fact, be infused into a human, similar to the Lantidra. They take up residence and they work. Now, there's still a problem. You still need lifelong immunosuppression because the immune system recognizes these cells as foreign. So Vertex, one of the leaders, has done a study, and it's ongoing now, called VX-880. And what it is taking these stem cell derived islet cells, beta cells that make insulin, and infusing them into study patients, and the results have been spectacular. This slide shows results from a year ago, 2024. At that time, a dozen people were infused with the target cells. Pretty much all of them became completely independent of insulin. And once they got to a year, it was really completely successful. So the study has been expanded to more patients. And at this point, the really exciting news is that it's entering into a phase 3 study. So when you do research studies, you have phase 1, 2, and 3. 1 and 2 they're in humans, and they're done to evaluate the safety of the treatment, maybe what is a reasonable dose of whatever the medication, in this case cells, is, and what is the efficacy, is it really working? So once you get through phase 1 and 2, then you can go on to phase 3, where you're treating a lot more patients to see what the practicality is and what it really looks like in real clinical practice. And this is super important because phase 3 pivotal studies, that's the one the FDA looks at. So the fact that Vertex is in phase 3 studies now is awesome, because next step is FDA. And this is some of the data. The green column is time in range. So the patients started out with time in range of about 50%. This is one person. This is the first person. And after a year, it was 95% time in range, and no, or almost no, severe hypoglycemic episodes where it had significant hypoglycemia before. First in human, this is Brian. Brian was the guy who had the first transplant. And that's Dr. Melton, by the way, on the left. So as I said, that's great and it's moving forward, but it still has the immunosuppression problem. Being on immunosuppressive your whole life is not easy. So Vertex took those very same cells and did some what's called encapsulation to protect the cells. Like they encase the cells in some sort of a material. They're not really forthcoming with what it is because it's in ongoing studies right now. So they encase them in this material and they implant them under the abdominal wall. And that does not need immunosuppression. That study is now ongoing, it's happening, and it's working really well. So super exciting. Um, the strategy on getting that, so this is a strategy on keeping the cells safe once they've been transferred into the body. So we mentioned encapsulation, which is what the 264 study is. You're literally taking a membrane or a barrier or a gel of some sort to protect the cells. Another way of doing it is scaffolding, which is almost like you bioprint an environment in which the cells can live that are implanted into the person. um, Another way of doing it is immune modulation, meaning you don't encapsulate, but you start to influence the immune cells so that they ignore the beta cell, they don't attack it, or you manipulate the beta cell so that the immune system doesn't see it. And one way of doing that is gene editing. You go in and you change the genetic makeup of the cell so that it can become hypoimmune and it can evade the immune system. So these are multiple different approaches to the same goal. And this is one strategy that Breakthrough T1D is pursuing, is to look at many options, because you don't know what's going to get to the finish line first. And also it gives you choices. So Breakthrough T1D has a beta cell consortium. Um, it's basically a group of uh, experts, scientists, researchers that all sit around the table and share information so that we can go faster. It's not about who gets there fast, it's about getting there. Here's an example of encapsulation. This is Cernova. Cernova is a company that Breakthrough T1D funded clinical trial. And these are donor islet cells. So they did come from a cadaver donor, but they are implanted inside the body in little pouches, so Cernova pouches. And those are studies are happening and they're working. So people are becoming insulin dependent with these little packages of cells in them. And they're lasting a long time, years. Now, this is like super, super exciting. This just came out last week. Sana Biotech announced that it transplanted some cells into a person and there was no need for immunosuppression and it wasn't encapsulated. These were genetically altered beta cells. So they took allogenic beta cells, meaning they were lab grown, or actually these were donor cells, excuse me. These are donor cells. So they took the donor cells and they removed from them the identifier that it comes from another person. There's a certain marker on a cell called HLA, and my HLA is different than yours, so that my body knows that that cell doesn't belong to me, belongs to you. So what they did is they removed the HLA marking so the body can't tell whether it's you or not. So that's one part. The second part is, as you know, if you have type 1, your body attacks your own cells. So in this case, it puts markers on the beta cell to tell the immune system, I'm safe, don't attack me. So they're just two aspects of the immune system. So they have created these hypoimmune cells from donor cells, and then they injected them into the muscle on the forearm of one patient in a very tiny amount, like 10% of what they think the final number of cells will be needed. And after a period of a month, this one individual, this first in-human person, is producing insulin and is increasing their insulin in response to diet. And that's in a month with meals. So this is so exciting. It's like changes are leaps and bounds. Other companies, Cernova, I touched on, clinical trials ongoing. Ceraxis has got a cell line. Minutia is a company that's producing little nano sensors. So nano, also cell lines, but nano sensors that actually live within the beta cells that can be monitored so that you can tell whether they're functioning or not. You can tell whether they're doing a good job or not. If they're not healthy, if they're not acting properly, you can actually kill them So you have a rogue cell, you can turn it off, basically. So it's a fail safe, it's a safety system, so that when those cells are transferred, you can keep track of them. So those are all companies that are supported by Breakthrough T1D in one way or another. So moving on quickly to disease modifying therapies. These are the treatments that you want to get into when you still have some beta cells. So the goal of this is to rebalance the immune system so that you can preserve your beta cells before they're gone. Remember my stages, stage 1 and 2, and early stage 3. And hopefully to be able to encourage the body to regrow its own cells. The things we're learning from cell therapies could be applied to this if you could imagine that you could alter a person's own beta cells so that the immune system leaves them alone before you get to the point that you don't have any. And so you take sick, stressed out beta cells and make them healthy again. So if you look at multiple drugs that are being studied, it's not just one. It's just a lot going on. Teplizumab is Tzield, which you may be familiar with. If you look at the dotted line, this is C-peptide. That means how much insulin is being produced over time. So this is an untreated person. As time goes on with T1D, you produce less and less insulin till it stops. When you give the drug, it slows that process down. And in this one, they actually improved. So these drugs are actually having an effect on delaying, halting, and to some degree, reversing the process that's happening. And Tzield is actually FDA approved. It's been around for a couple of years now. And it's to be used in stage 2, people who have 2 antibodies and they just have some blood sugar abnormalities. And when given to those guys, it can delay the onset of stage 3 or actual T1D for 3 years, which is fantastic. Now it's also being studied in stage 3, so early onset T1D, in order to prolong their honeymoon period and even to get them off insulin for a short period of time. It can't stop it yet, but it can slow it down. So also another aspect, improving lives. So say you're not an early stage, you're stage 4, we want to make your life better now. This is again looking at that diagram that we looked at a little bit earlier, is the automated insulin delivery system. Delivery systems that will help maintain and improve glucose metabolism while we're waiting for that cure. And as I pointed out, you can see over the last 20 years, this is from Medtronic AID system to today, where we have many new systems coming out all the time. All T1D funded or supported or encouraged, got through the FDA through efforts made by T1D, got through regulatory, got into development, and coming to you. I mean, it's there. We've got it. So the AID systems, which are now plentiful in the United States. Okay, so we're good. We can quit now, right? Well, no, there's still room for improvement. So you know what a continuous glucose monitor is. It measures your sugar from minute to minute. But we mentioned ketones earlier. Ketones happen when the blood sugars are not being properly monitored, and you get ketones, which makes your blood acidotic, which makes you fall into decay, which is very, very serious. So there are continuous ketone monitors. So we'd like to see those and maybe incorporated into the AID system. So you have a glucose monitor, a ketone monitor, an insulin pump, and that they talk to each other through algorithms so that it will be able to monitor and uh, raise and lower the blood sugar more appropriately, and also to head off DKA and warn someone when they're getting into trouble. And then also that the AID systems are much more responsive to dietary habits. In other words, they're going to respond to meals, because AIDs are hybrid closed system, meaning they work by increasing and decreasing insulin with your blood sugar, but you still have to have a human being that says when you ate and how much you ate. And eventually what we want is a system that will do that without a person being involved at all. You strap it on and it works. And of course, insulin is what is keeping everybody going right now. And insulin is clearly not enough. I mean, most people are not in good blood target ranges, and still long-term complications are happening. So how do we improve on insulin? Well, there's multiple drugs you can use with insulin. First of all, insulin can be made smart. There's such a thing as smart insulin, which means blood sugar. When the blood sugar goes down, insulin shuts off so that people don't get hypoglycemic. So that's what basically what smart insulin is. It's not commercially available yet, but having that would obviously save a lot of low blood sugar events, which would be admirable. But you can take insulin and combine it with a drug like a GLP-1, which is very protective about long-term complications and does help to stabilize the blood sugar. And also Farxiga, which is SGLT type inhibitor, same thing, can stabilize blood sugar and can guard against long-term complications for heart and kidney, and put those drugs together to get a nice balance and a better, easier life for those living with T1D. The ketone monitor is extremely helpful because one reason we can't get this drug approved to be used in T1D, the Farxiga or the SGLTs, is because they make you prone to DKA, diabetic ketoacidosis, which is life-threatening. So FDA isn't allowing it to be used in type 1 officially yet. If we have a ketone monitor that de-risks that, that makes it easier for the FDA to say, okay, let's let the guys with T1D have this drug too, which is very beneficial for long-term side effects. And the long-term complications and side effects, of course, have to do with blood sugar control. So the more control we have, the less complications. But still a lot of research going into how to manage and how to make these complications more treatable. So we're covering the entire gamut. And obviously in 45 minutes it's hard to do, but I have tried to hit some of the highlights and give you an overview. Clinical trials are critical. If you don't have the trials, none of this will happen. All of the breakthroughs are happening because people volunteered to be part of the study. So if you or someone you know has T1D, or certainly get early screening so that people will know what their risks are. And you can go to the breakthrough-t1d.org clinical trials, and you can find a clinical trial in a minute in your area that would be appropriate for you. So it's just breakthrough-t1d.org/clinical trials. And if you're into research and you want more information, go to the website, sign up for the pipeline, which is breakthrough-t1d.org/research. This is a monthly newsletter that comes out with all the new things, and it's really, if you're into it, you're gonna love it. So I'm gonna turn this back to Wendy now, and she's gonna talk to you a little bit about the community summit.
Thank you so much, Susan. That was amazing. So much hopeful and exciting research taking place right now. Really appreciate you taking the time to share this with us. Which coming up for those living in Arizona on February 22nd, I'd love to invite you to our community summit, where you'll hear more about research, you'll learn more about technology, you have the chance to learn more about clinical trials and screening and much more, and visit with one-on-one with a lot of our national diabetes sponsors. So if you have any questions, please feel free to reach out to me. And now I'm going to turn it back over to Susan. Again, thank you, to open it up to Q&A. And as we mentioned at the start of our presentation, to please put any questions you have in the chat, and we'll monitor that and hopefully get to all of them. Thank you.
There we are.
Awesome. Do you want me to jump in, Susan, and share some of the questions?
Yeah. Am
Okay.
I seen? Do you see me?
Yes.
Okay.
I
Yeah.
do.
Fire away, and
Awesome.
I'll do my best.
Okay. This one hits home with being a dermatologist, Susan. Anne asked, do you have suggestions for the skin reaction to the adhesive on CGMs? I realize not a related question to what's being talked about. Oh, sorry, I didn't mean to add that. But what a great question, because my son has those same issues too. But yeah, so any thoughts about skin and the adhesives on those CGMs?
Yeah, that's a tough one. I mean, allergic reactions to the gum, the adhesive is very common, and all kinds of adhesives used in medicine have the same problem, like estrogen patches and all that kind of thing. Rotating it you know, using hydrocortisone on the rash as you get it. But we don't have an answer to that. I hate to tell you, rotating the areas, don't put them in the same place, and use a 1% hydrocortisone on the irritation as soon as it happens.
Okay.
The best you can do.
Thank you. And you know, many of the questions that came through when our attendees were registering, you covered. So I think we're in excellent shape. I'm just kind of reviewing it again, making sure. There was one question that came through at the just talking about, you know, insurance coverage. So let's say, for example, you've got family members that have type 1, and then you do, you know, you do the screening and find out you have the autoantibodies, and it's, as we know, it's going to lead to type 1. Is that considered a pre-existing condition?
Oh, geez.
That's a,
Yeah, that's a regulatory question. I hate to tell you. I would say at this point, no, but I'm not an expert on that one.
yeah, that is,
But
we'll
I
do
think
more.
that I understand the concern. Like you don't want to get identified as having the condition, but to look at it on the other way is that if you're going to have it 100%, it's sort of like, don't put your head in the sand and go, you know, it's not going to happen. One of the reasons to screen is you can do something about it. You know, back in the day, what would be the point? You can't do anything about it. But as of 2 years ago, there's T-Shield. So if you have someone who has 2 antibodies, you can delay the onset by 3 whole years. And is that a big deal? Yeah, if you got an 18-year-old, they can get through college without having type 1. If you have a 3-year-old, they can get, you know, into 2nd grade. So it's massive, and psychologically for the family, for the person, if you're an adult diagnosed, that you have time to understand, educate yourself, to prepare. And also then you don't get people presenting with DKA, and people die from DKA. You know, kids end up in the hospital seriously. So it's usually kids. So many reasons to screen, and that makes that pre-existing condition, which is now less of a big thing in America. I mean, most of our insurance companies are not allowed to do that. I think you still should screen. Yeah.
I agree. And along those same lines, Susan, a question came up: should first cousins be tested for the autoantibodies? We
So
know that, you know, if you,
yeah, right now, it's first degree
Mhm.
relatives, you know, so brothers, sisters, mothers, fathers, you know, sons. So a first cousin would not necessarily, but I mean, ideally, you know, everybody should be screened, because it's only about 20% of people diagnosed with T1D who have a relative who also has T1D. So that means 80% are not. So that what the goal is that we want to get to is that it's universal screening starting in early childhood. And in some countries, they're getting more towards that than we are. Right now, low-hanging fruit is relatives. If you have a T1D relative, that, yeah, let's get them tested. But that's not even the majority of people diagnosed. So yes, still
yeah.
should. So yes, the second cousin should get tested.
Thank you. Well, that's it for the questions, because again, you covered. So I'm just kind of doing a quick
So there
review.
was a question that we got ahead of time about China doing some studies on growing stem
Yeah,
cells. And that was a study that came out fairly recently. So Chinese scientists basically took a cell from a person and created stem cells from that person's own cells, grew beta cells, implanted it back into them after genetically manipulating it to make it hypoimmune into that same person. It's fairly similar to what we're doing in the United States, but in the United States, we're focusing more on make stem cells in a laboratory allogenically, meaning that is not individualized. It's you don't need to give Susan cell. You can have a vat of cells in the lab that everybody can use. So they're lab engineered beta cells. So in China, what they're doing is they're taking individual cells and giving it back to that individual, sounds like a good idea. It's not really a good idea because it takes years to do that. You have to grow those cells. In the meantime, the person is sick. And can imagine the money cost prohibitive to make those cells. And there's no real advantage to it because, as we've already discussed, people with type 1 have immunity to their own cells, autoimmunity. They attack their own cells. So it's not really an advantage to give you your own cell because you hate your own cells. You still have to, I still have to engineer them, right? So China is looking at it a little bit differently, but it doesn't look like it's a superior way. It's just a different way.
Gotcha. Okay, that makes sense. I thank you. Does anybody have any other questions? We are so appreciative that you joined us tonight. And Susan, thank you so much. I mean, really, it's every time I just love hearing all the great news, the progress, and it's so, I guess, to drill it down, just when you see the template, right, of how from
Hmm.
discovery into the hands of clinicians to type ones, they've got the footprint, the template, so to speak, and now with the cell therapies, science is moving so fast, so it's really exciting.
And
And
what breakthrough T1D does to accelerate it is just astounding. I mean, the breadth and depth of this organization that affects every single stop point along the way. I mean, that's why this is happening.
yeah, yeah, I mean, as a mom of a T1D, it's hard to even
Mhm.
talk about because we all want it. It's so exciting and we're getting so close. So thank you for presenting tonight and thank you all for joining us and hopefully you can jump into the summit. And
Absolutely.
Celia, thank you. So thank you, Susan, for sharing your incredible knowledge. It's so helpful.
Thanks, everybody.
Yeah. Take care and have a wonderful night.
All right. Good night.
Good night.